Hello everyone, this is Soumya from Third Eyes. Here I'm going to present an animated video about address translation. What is virtual memory? Virtual memory is the technique of using secondary storage such as disks to enter the apparent size of accessible memory beyond its actual physical size. Or it is defined as an architectural solution to increase the effective size of the memory system. Physical main memory in a computer is generally not as large as the entire possible addressable space. Physical memory typically ranges from a few hundred megabytes to 1 gigabyte. Large programs that cannot fit completely into the main memory have their parts stored on secondary storage devices such as magnetic disks. So that pieces of programs must be transferred to the main memory from secondary storage before they can be executed. Some other piece in the main memory must be replaced when the main memory is full. Operating system automatically transfers data between the main memory and secondary storage. Techniques that automatically move program and data between main memory and secondary storage when they required for execution are called virtual memory techniques. But the question is how the address is translated. What is address translation? Let's discuss now. Binary addresses for instructions and data. These binary addresses are called logical or virtual addresses. Virtual addresses are translated into physical addresses by a combination of hardware and software subsystems. If virtual address refers to a part of the program that is currently in the main memory, it is accessed immediately. If the address refers to a part of the program that is not currently in the main memory, it is first transferred to the main memory before it can be used. Memory Management Unit, MMU, translates virtual addresses into physical addresses. If the desired data or instructions are in the main memory, they are fetched as described previously. If the desired data or instructions are not in the main memory, they must be transferred from secondary storage to the main memory. MMU causes the operating system to bring the data from the secondary storage into the main memory. But how does the address translated? Assume that program and data are composed of fixed-length units called pages. A page consists of a block of words that occupy contiguous locations in the main memory. Page is a basic unit of information that is transferred between secondary storage and main memory. Size of a page commonly ranges from 2K to 16K bytes. Each virtual or logical address generated by a processor is interpreted as a virtual page number, high-order bits, plus an offset, low-order bits, that specifies the location of a particular byte within that page. Information about the main memory location of each page is kept in the page table. Main memory address where the page is stored. Current status of the page. Area of the main memory that can hold a page is called as page frame. Starting address of the page table is kept in a page table base register. Virtual page number generated by the processor is added to the contents of the page table base register. This provides the address of the corresponding entry in the page table. The contents of this location in the page table give the starting address of the page if the page is currently in the main memory. Page table entry for a page also includes some control bits which describe the status of the page while it is in the main memory. One bit indicates the validity of the page. It indicates whether the page is actually loaded into the main memory. And BSP allows the operating system to invalidate the page without actually removing it. One bit indicates whether the page has been modified during its residency in the main memory. This bit determines whether the page should be written back to the disk when it is removed from the main memory. similar to the dirty or modified bit in case of cache memory. Other control bits for various other types of restrictions that may be imposed. For example, a program may only have read permission for a page, but not write or modify permissions. Where should the page table be located? Recalling that the page table is used by the MMU for every read and write access to the memory. Ideal location for the page table is within the MMU. Page table is quite large. MMU is implemented as part of the processor chip. Impossible to include a complete page table on the chip. Page table is kept in the main memory. A copy of a small portion of the page table can be accommodated within the MMU. Portion consists of page table entries that correspond to the most recently accessed pages.